Yeah, so we say that we identify a set by the content of its element. The element of each set, like its content. So what happens is that when you are given two sets, sometimes they might ask us to find the union or the intersection of the set. For the union, we use the like this symbol that is like a U, capital U, and then for intersection, we use the symbol, the reverse, the other way of U, which is this one. Mathematically, I don't know whether we'll get there. The U is like seen as a plus, and then the intersection is meaning multiplication, right? So we'll get there maybe on the probability side. So something like yeah, so the U is this one, and then the E is multiplication behind the scene. But then, so the way I actually remember how to operate them is that I look at the U here, and the U here is like a cup, like just a cup, a drinking cup. So it's as if, okay, it's like this, so everyone should pour their thing inside. So basically for the union, we try to put elements that are in A and elements that are in B together without repeating any. So if there is already an element that's inside the union, but that's coming from the other side, if it's already inside, we don't put it, we skip to the next element. So let's use an example. Let's say A is this set 1, 3, and 5. Then we have B is 4, 5, 6. 4, 5, and 6. And we are asked to find the union. So when I see the U like this, because sometimes they confuse me. So when I see the U, I mean like that's a drinking cup. So everyone should pour their tea inside. So what happens is that I look at A, there is 1 there is 3 there, and there is 5 there. So I copy 1, I copy all elements here. Then when I go to B, I look at 4. 4 is not inside already, so I'll put 4 there. 5 is already inside, so I will ignore it. 5 is already inside the union, so I will go to 6. And I'll go to 6. We say that for sets, we don't actually worry about the order mostly, but it is preferable that if you are handling numbers, you write them in order. So this one, 1, 3, 4, 5, 6. It's just a preferred something, unless a special case that we'll see ahead where you have to keep the order in mind. But for sets, we don't care about the order. We worry about the content. What we need should be inside. We don't really care about the order in general. So for a union, so I take the first one, I write all its elements inside, then I go to the other element, and when I'm writing them one by one, I check if that particular element is already written. If it's already written, you skip to the next one, and at the end of the day, you have everything put together. Now in the same vein, we will see we'll do intersection as well. For the intersection, the U, so if it's not U, it's going to be the other one. So the intersection is mostly concerned with what they have in common. What they have in common. So it's not, so it's just a set that contains everything that A and B have in common. And for that one, I think it's easy. So 1 is here, 1 is not here. 3 is here, 3 is not here. 5 is here, 5 is here. So 5 is something in common. Then 6 is here, 6 is not here. So it's like it's only 5 that they have in common. It should be a set. That's why even if it's one thing, it should be a set. If there is nothing there, if there's nothing in common, then we will have to put the empty set there. Another way of writing the empty set is doing this. Right, so don't do this. This is not the same as this. So empty set alone, this is like 2 empty sets together. All right. So for intersection, it's just like intersect, like what they have in common, and for the union is what we did previously. Yes.
I think the concept is not a problem, but the way you because you said intersection was multiplication, or you were talking about it in probability terms.
Yes. When we get that's what I'm saying, that behind the scene, we'll use it when it matters.
Okay.
But right now it's not really needed. Yeah, in probability terms to need it. It's very well there. And sets broad. And this particular thing, they just say set. And I don't know how deep they will go or how light they will go. But because the thing is a lot, I guess we just touch things that were not covered in high school and I've been done in universities. So yeah, so intersection and union, that's it. The next one is relative complement. Relative complement.
That's the next topic. Yeah.
Yeah, next concept. Another word for it is just the difference. Difference between two sets. I mean the minus thing. Yeah. So relative complement actually is so we had A. I think I had A was 1, 3, 5, and B is 4, 5, 6. Yeah. 4, 5, 6. So we have to find a complement, relative complement between A and B. So that's the difference A minus B. So it means that, so this one just means that take A and remove anything that is in B from A. Take A and remove anything that is in B from A. That's what A minus B is. So it's also going to be a set. But if you consider A, so 1 is here. So 1 belongs to only A. It's not in B. So you write it down. A is here. 3 is here. 3 is not in B. So 3. 5 is here. 5 is in B. So we are not including anything that is, so we are done. So take A and remove anything that is in, any element that is inside B, right, from A. That's what it means. So here 5 is here in A, all right, but that 5 is found in B, so we remove it. So it will be left with 1, 3. So 1, 3 is the element that only solely belong to A itself. It doesn't belong to B. It solely belongs to A itself. It doesn't belong to B. That's what it does. That's the A minus B. If you do B minus A, B minus A, that will be, you take B and then you remove anything that's inside A, like that's inside A. So you see that 4 belongs to only B, 5 belongs to both of them, so you ignore it, and 6 belongs to only B. So then you have this. So you can see that A minus B is not the same as B minus A. So this is one thing. I mean, these are just basic stuff.
So in other words, it's like if you do A minus B, it's like you are trying to just find solely A elements without anything that appeared in B.
Yes.
Okay.
Now, we know that a set deals with holding elements, I mean containing elements in general and all those blah blah blah. But actually, if we are talking about a group of objects that we want to group together, and actually we need to have a well-defined barrier, right, that relate to all those elements. So I mean, when you want to group anything, let's say you go to your room and you want to group objects in your room. I mean, how do you call it? Spoons will be in a particular cup. This thing will be, your books will be here. This like you are arranging your room. At the end of the day, you are not dealing with the entire world. You are having a boundary that you are working with, and you are focusing on everything within that boundary. So that's just your room. So you are arranging things specifically in your rooms. So you generally have that how do you call it, global boundary that we set, and then within that global boundary, then we form different sets inside, and those sets inside may be intersecting, non-intersecting, or whatever. That particular boundary, we call it the universal set, right? So universal set, we generally, when we are drawing it, we met before, that's like a box, just a rectangular box. We call it the universal set. And inside it, we have different groups inside. And then some are intersecting, some are not, some are disjoint. So sets that are, so this is set A, set B, set C, set D, E, right? You see that A and B are disjoint, meaning they don't have anything in common. And then set, all right, all right. Sorry about that. So A and B are disjoint, something like that. So I'm just trying for right now, I'm just focusing on the universal set. So universal set is like we are setting a boundary, a rule that defines every element in that particular group, and then within that group then you form subsets. That's what we call the universal set. Now within this universal set, we talk about relative complement, right? Something that is in A but not in B, and those, or like those things that we said. But that's a relative complement. Is being compared to another set. Is being compared to another set. But if you are comparing that to the universal set, it means that, let's say you have A, right? This is A itself. Anything outside A is the complement of A. Anything outside of A within the universal set is called the complement of A. I know this thing we are used to be already, but I just want to just state it again. Anything outside of A is called the complement of A. So anything, even B's, D, and everything that's not found inside A is called inside complement of A, and but they are all within the boundary of U, which is the universal set. So the complement of A. So complements of A items may be found inside A, inside B, inside C, and inside everything, anything that is outside of this round box for A. So for the symbol is A, like prime here, or some people do it like this, with a bar on top, right? But we'll be using the bar on top here. Right, so this is the A complement. So the A complement is this. Anything outside of A is called the A complement. So if you take A and then you add the complement to it, you are going to have the universal set. Hello, are you saying something?
No, I was saying we'll give you the universal set.
Yes. So I say yes. And I say you add something to it. So add means that you are finding the union. So that's what A union A prime, A complement is the universal set, basically. So these are the basic stuff that we know. There will be things that we're much more worried about. Okay. Now that we know the universal set, an example of, let's say we have an universal set of this, the master. Yep. So let's say our universal set is equal to the set 1, 2, 3, 4, 5, and let's say A is 1, 3, 6. Then we have to find the A complement. What do you think will be the A complement?
2 and 5.
5. So is there any other suggested answer, or that's okay?
That's fine. Or you add it now? I doubt.
The what?
5 and 4.
The now set.
It's supposed to be 4.
It's supposed to be what?
You have to add 4.
4, 4, 4.
2, 4, 5.
5. Yeah.
Brajeron, do you also think same? Maybe his network is issues. All right. Actually, the question itself is not valid. It was intentional, right? The universal set defines every object that you should be working with. But you see, A is having 6. I intentionally put 6 there. So these things are not related. This question is wrong. So A cannot have anything that's not inside the universal set. Yeah, so this question is invalid question. So because I wanted to set the base that first you need to know that the set, you should look at the universal set and make sure that everything that is set out of, it should be formed out of the universal set. Anything beyond that is actually incorrect. So the 6 is not supposed to be here. So it was supposed to be 5. So if it is 5, then our A complement is I think you said 2 and 4. Yep.
Yeah.
All right. Yeah. So the complement obviously depends on the universal set in which we are working. All right. Let's go to more complex math concepts. Yeah. Now we've done the difference. Now we are going to a concept called the Cartesian product. Cartesian product of two sets. So here, okay, I had A. Let me use the same A. This 1, 3, 5. One 5, 2 5, right? 2
4 5 6
all right, let's keep this one. So I'm just trying to find the Cartesian product of this. So I'm doing A multiply B. So you see that you said
Cartesian. I was just asking the spelling of the Cartesian.
Cartesian. It's like Cartesian plane. S and Y plane.
Okay.
So you remember that when we were having this one in terms of the vectors, we were calling it cross product. I mean this sign. But here for set is Cartesian product. Or you just say product, but it's Cartesian product because of the unique way that we handle them. Alright. So how do we find the Cartesian product of two sets? It should actually be an ordered pair. So the way we handle this is we actually form a table. To find the Cartesian product where let's say A elements are 1, 3, and 5, and then the B elements are 2 and 5 here. So we try to group them in look at how it's being done in brackets, not curly brackets, in parentheses. So that will be one. This one first. What comes here? I mean, like whatever you have here should be for A, and whatever you have here be for B. The order, this order. So this is the case where you have to worry about the order, right? The case where you have to is when you are defining the Cartesian product. You should follow that particular order. Very important. So this will forming the ordered pair. So this one will be 1 and 2, and this one will be 1 and 5. So you do the same thing for this, will be 3 and 2, and then 3 and 5, then 5 and 2, 5 and 5, 5 and 5. Yeah. Now we need to write the product itself. For the product, let me clean this thing. Yeah. So for the Cartesian product itself should be a set. So these are the symbols that they forget, right? Because people think, like, assume they know, like the A and B, the cross product should be a set inside like this. And inside that set, for the set we use curly bracket. Inside that set, you state the pair, and the pair should be in parentheses. This is 1, 2, 1, 5, 3, 2, 3, 5, 5, 2, 5, 5. Then curly brackets close it. So because it should be a set on its own, but the content should be inside the parentheses, and that is called the Cartesian product of A and B. Please, are we good?
Yes, please.
All right. You see that another thing to note here is also this one will mostly be about your notation. If one of them you put a forget and do curly bracket around one of them, the whole question is wrong, because it will not be read mathematically like that. So I mean, that's why they say maths people, they are very strict. But then because they are reading the things, the symbols and everything differently, and if it's not the same, so let's say we are finding the magnitude, right, or the cardinality of A and B, right? A cross B, no, yeah, A cross B. Oh, it's not cross product. A times B basically. So Cartesian product, it should be is equal to how many things that we have here? 1, 2.
I cannot hear you. Why don't you?
All right, I'm saying that. Can you hear me now?
Yes, I can hear you.
So I'm saying that we are talking about the cardinality of the A times B now, which is why I brought these two symbols. And when we have cardinality or something like that, you know it's a number. So here we are talking about the number of items within the set. Here is 1, 2, 3, 4, 5, 6. There are 6 of them. If you see that there are 6 of them. But then we have to note that A cross B, right, the magnitude or the size or the cardinality of it is equal to, actually, you can find this times this. You have the same answer. So assume they give you something very long and you have to find the cardinality of the A cross B. You just multiply all of them. So you see that A was 135, and so A was 135, and the other one was 2 and 5. So the cardinality of this is 3, and cardinality of this is 2. That gives us 6. So because sometimes they will give you a long set and things, but the section A or whatever, they are just looking for you to just select, tell them the A cross B, and people will be trying to do the pair, the table and things before trying to count. By just basically doing the 3 times 2, if you know this particular concept. So even if you have 3 sets, 3 sets. Yeah, 3 sets. Let's say if I have another set like this, I have 1, 3, 5, 2, 5, and then I have 2, 5, 1. For example, as my set, what we will have to do is you first have to do your A cross B. Like you do these two first. You do these two first. When you are done with that, Like you do this to get your this, and when you are done, you cross it with let's say this one is a C, the set C. Then you use that against C as well. Then it will give you the output. I mean, a long, I think,
Now the three ordered, they become three ordered pairs.
yeah, 300 pairs. Then, like, so you have to make sure you follow that order. If it is something that will give you like A cross B is not the same as B cross A, it's not the same. A cross B is not the same, it's not equal to B cross A. I mean, what you can do is just swap the 2 and 1, I mean 5 and 1, 3, 2 and 3, and all those stuff, but know that they are not the same. Usually they test these concepts, I mean in quizzes, small quizzes, they do that before the final exams. So they are not the same, because 3 times 2 is the same as 2 times 3, but it doesn't happen for, just like how we did it for matrices. It's like I'm rushing today. Oh. But yeah,
Can you take it again?
all right.
Yeah, can you take it again? After writing the pairs, I'm okay from to that end.
All right.
The rest of the stuff there,
Okay.
I didn't get them clear.
Sure. And do that. So after writing the pairs, we have this particular A and B. So from there, what I did was why did you go like that? Okay. So after writing the pairs, the next concept I was tackling was the cardinality or the size. And for the cardinality, we know our friendly symbol, which is this A cross B. Around the entire A cross B, we have these particular 5 signs, which is telling us that we are trying to find the magnitude or the size or the cardinality. However, you have captured it in your mind. Then that means that count the number of items inside the set. So there is 1 here, 1, so that's 2, 3, 4, 5, and 6. So there are 6 of them. And we are saying that if you know the cardinality of each of them, right? So A cross B, if you want to know this cardinality, it is also equal to A dot. So when you find the cardinality of A, you multiply it by the cardinality of B. And the cardinality of A was, the set A was 1, 3, 5, and B was 2 and 5. So looking at this, the cardinality of A that we had was 3. So I write 3 times, because that's what we want to find. The cardinality of B is 2. So 2 times 3 is 6. That's the same as what we counted inside. So then I started saying that during session 8, right, they'll give us sets, they'll give you sets and ask you to find like the cardinality of the cross, I mean a Cartesian product like A cross B. But you don't have to go through making the tables again in order to find the pair before counting. What you just have to do is that you take each original set, you find the cardinality of each of them, then you multiply them. So in this case, we have 3 times 2, then we had a 6 when you come to the size. Then, Rajaram, please, do you follow? His network. Please, can you hear me? Can you hear me? Is my voice? Is it me?
We can hear you.
Rajaram.
He's muted though.
Yeah, Rajaram, you are muted though. Please, we are talking. This one there, I have to lock in all my stuff and then upload all videos today for him. If not, I'll be in trouble. So how do we? Let me test him. See. I have to make sure I send this video today. Yeah, but for sets, I'm just trying to make sure that I didn't skip anything, because we are at the end of what I plan to teach on the set.
Okay.
Yeah, so I want to make sure. Yes, that this time we didn't, unlike matrices where every concept is new, that I have to give questions for each of them that way for us to try, right? I think that was what was taking time.
Yeah.
Which is, yeah, we just try some questions and then send the video. So that sets we are done.
Health network is really bad because it's not even off.
Oh, so the network is really
So
good.
maybe when we are done the videos,
Yeah, I have to stop everything other thing and do it for him tonight. I'm even uploading one. It's at 79%. Since so. Oh, he's left. Oh God. Alright. So basically those are the general concepts around sets that we need to know. And then I have some questions here for us to try for the rest of the period. Okay. I have an interesting question. Very interesting one. Okay, let me go and click the first one.
interesting means it's tricky.
Oh no, it is not coming from me, so I don't trick. Let's see if we can get this. We have universal set is equal to 1, 2, 3 up to 10, right? Normal up to 10. Then we got A to be 1, 4, 7, and 10. B is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And C is 2, 4, 6, 8. We are asked to find this A intersection B union C, but the bar is on top of A and B. Direct, one straight bar on top of A and B. Union C. So this is the question. This is the set that we need to find.
Okay. Should we try it on our own?
Yeah, try it, then just come in and solve it together to confirm.
Okay. Please, I'm done, Francis.
Oh, all right. What do you have? Let me use blue pen.
Answer is the set of 2, 4, 6, 8, and 9. That's the final answer. But I got the A prime to be 2. Oh, you just want the final answer?
Yeah, the final answer though. But you say you have A prime to be what?
1, 2, 3. A set of 2, 3, 5, 6, 8, 9. And then prime.
If this is the approach, then there is an issue.
There's an issue, eh?
Unless I confirm the final answer. Let's wait for my boss to also finish. Then we'll confirm both.
Okay.
What I got was 2, 3, 5.
For the final,
3,
Yeah,
5.
for the final answer. 6, 7, 8, 9, 10.
All right. So let's go through this one by one. So now the thing is we are finding A. So you see that it's A intersection B bar first. You need to find this first. So you need to take it pair by pair. But this bar on top of these two, you need to address them. Be very careful. You have to do the A intersection B first because the bar is not on top of just A.
wait. So when you were reading it, I heard you say A intersection B, then bar. So I was thinking the bar is A bar intersection B bar. So that's what I did.
Oh no, I said
No.
A intersection B bar, meaning like you are, that if you are reading, you have to read. I mean A intersection B, right?
So what I'm saying, like, is just the way I noted the question.
Oh, okay.
I did A bar intersection B bar.
All right, all
I
right.
didn't do all of them bar.
All of them bar, yeah, it's all of them bar. So
But
to have,
what I did, no, the question be given in that way, like A bar, B bar, union C. Like A bar intersection B bar, union C.
this question is not the same as this one, the one I gave.
I know, but I'm saying is can a question be given like
Oh
that?
yes.
Okay, so please, when you are done, kindly solve that for me because that's what I did.
All right.
So I think I'm wrong because I actually did copy the wrong question. So
All right. Yes, no problem. So A intersection B. So we have to find A intersection B first. Then we bar that A intersection B. So A intersection B, what is inside A and B? A and B intersecting. So what is inside both? 1 is in both A and B. 4 is inside. And that's it.
Yeah.
Yeah, so this is the A intersection B. Now we are going to do the bar of this. I mean, related to the universal set. So meaning that everything inside the universal set.
Complement.
So that will be 2, 3, 4 is not inside, 5, 6,
5,
7, 8,
8.
9, 10. And we are just doing union C. Union C is 2, 4, 6, 8, and 2, 4, 6, 8 are already inside. So this is the answer actually. So I think this is what we got here. All right. But is the procedure okay?
yeah, it's fine.
All right. So let's solve.
So what I want, solve the other one.
Nick, can you mention your question?
So I did A bar intersection B bar union C.
Okay.
So A bar will be 2, 5, 6, 7, 8, 9. Yeah. So this is A bar.
Ah, exactly. So that's what I got as A bar.
Go to B bar.
6, 7, 7 to 10. 8 to 10.
Now intersecting of these two.
Yeah.
Um
You are gonna have 6, 8, 9.
uh-huh. Then you union this with
Union
this.
them with the C.
That will be 2, 4, 6, 8, 9.
4, 8. Yes. So that's what I got.
Yeah, that's fine. All right.
Because I just said my own question.
All right. There's more questions coming.
So I started raining here.
It's really nice around there.
It's really on my end.
Oh, okay.
A union B minus into bracket C minus B. Yep. Another solid one.
Are we doing using the same pair of
They're the same A,
sets?
B, and C.
No, I mean the same. So the same numbers, right? The same elements.
Yes.
Okay. Please, I'm done now.
Oh, all right, all right. Let's see what we have.
I have the set of 1, 2, 3, 4, 5, 4, 5, 7, and 10. I'm wrong, eh?
I don't know. I honestly don't know yet.
Okay, so A union B
I
is
had the same thing.
You had the same thing.
Yeah. The answer is equal to A union B.
yeah.
Really? Okay, A union B is what's it? Where are you? Where are you? Where are you? So A union B will give us 1, 2, 3,
4, 5,
and then
7, and 10.
C minus B.
Francis, I hardly can hear you guys. So
Oh, the rain.
yes,
Oh, we can hear you.
We can hear you very well.
I can hear you painting.
Okay, don't worry. I will shout. Don't worry. C minus B, that would be
6 and 8.
6 and 8. Okay, yeah, it's 6 and 8. So, then this one will not even do anything. Yeah,
Exactly.
this is
That's what
yeah, all right. So yeah, so I mean, I didn't test the other aspects of the set that we learned, but um, most of the questions are around this.
Mm,
Okay,
I think maybe the difficult one will be the ones that they bring the equation. Is it the ones that you made us solve yesterday?
yeah, I have some here. That's why I'm cleaning the board fast.
Okay.
So now next one will be functions, and then the functions, the introduction, and the video that I send the playlist is I'm the one who taught it myself. So
please kindly speak louder for me, I beg.
yeah, I will even test it in the group. So
Or if possible, we can do it another time because I cannot hear anything.
yeah, we'll meet tomorrow. Tomorrow is when? Thursday. Hey, wait, Thursday. It's 6 p.m. right? Hey, tomorrow is when?
Yes, yes.
Yeah.
I can't hear you.
I think we need to
Hello?
close. Yeah, I will test in the group.
Yeah, Nick, he's saying that tomorrow is 6 p.m. But he just wanted us to give, he wanted to give us one question more to solve. That's all.
Okay. Sure.
Okay, yeah. Thank you very much, Brad David. Let me see. A equals to 1, 3. B is so we are confirming, we are trying to see if
Yeah.
no, it's 1, 2. B is x such that s cube a minus 6s squared plus 11x equals to 16. So yeah, we are trying to find if A, B. So this is the question. Boss, do you get it?
Yeah.
Yes.
All right.
Now, this cubic table, are we going to use matrix to solve it or what?
Let me lower the question. And there's no calculator there, so let me just.
Oh, you don't go. Okay.
Are you saying something?
Yeah, I'm saying that let me just remove it because you don't have calculators there to do the factorization.
I can get the. Okay, let me get.
Okay. If you can get it, then you can help me.
Yeah, so that we can use it. So x is equal to 4.192.
So what did you use to get that?
The rational root theorem or something.
On the calculator.
Yeah, on the calculator.
Hey, I'm not sure. Is that the only answer?
A minute too. So like -10 and -10.
And then negative. So negative 10. But
That's what I'm seeing.
this cubic thing.
But finally, if you can solve it, or you can solve it now. Make your cry meeting.
I also need a calculator, a serious calculator. But it's Brad Jerome that knows how to use the Casio. The engineering calculator, I didn't bring it home. I left it on campus.
Because the calculator, all you have to do is when you enter the equation, then you click on Shift Solve.
Yes.
So that's what I did. So it's not.
Okay. Then if it's based on this, it's not this. So let me just change the question for. I mean, we need to solve at least one question before we go.
Okay.
This is this question now.
Okay. Yeah. How can we do it? Yeah, so I think it's correct. To A is equal to B.
So what do you have for X?
I had -1 and 3.
Francis,
Yes.
unfortunately, my network went off, so I just have to log out because even if I should continue, people have gone far.
Oh yeah, don't worry. We are having just solving question.
Okay.
Francis is correct too.
Yeah, it's correct. I've just confirmed. Yeah, it's valid. All right. So the functions video that I was saying. I think the rain is down now. Okay.
For Nick.
Yeah.
I can hear you. I can hear you this morning.
Oh, okay. So next will be functions, right? But for this one, yeah. Next will be functions, and after functions, some extra concepting. So I think we can do functions tomorrow. But the video that I sent are the introductions to functions, and mostly that's what I will talk about. So if you go through it, will help us so that we can move forward fast.
Okay.
Yeah. So we'll meet tomorrow 6 p.m. then.
All right. So if we don't go through it, yeah, it's our own loss. Eh?
Oh,
The
no,
video
no.
for
Tomorrow I will just come, then any concern or anything, then I'll address all of them. If he hasn't gone through, then you want me to just take it over, I can do it.
No, I'm talking to the video is for Jerome. I thought you said you are sending introduction of function video too.
you sent it already.
I sent it already.
Ah,
It's on the
okay.
page.
Okay, but it's the same thing you talk about tomorrow, right?
Yeah, so that's why I'm sending it.
Oh, okay. Hmm.
So if you go through,
Thank you.
I just answer the questions that you have around it, then we move forward.
Okay.
Okay.
Okay. So set is done. Oh. See you next time. I need this week. This week we should be able to be done with certain functions.